session.
Thank you so much. It's a pleasure to be here. Welcome to everyone attending, and I know some of you are still getting in. So just want a couple of introductions here. And as you can see on the slides, those pictures are really just both of me. The picture on the right was me before 2020 and the COVID stuff, and the picture on the left is me after 2020. No, but seriously, that's my colleague Hugo. You see him in the video over there. And I'm going to be presenting the, I just had a message pop that said show my screen, but I think my screen is being shown. Is that correct?
I don't think so, Bob. I don't see your screen.
Let me do that. Let me do that right now, because they did it in the first one, so I didn't have to do that. So I'm going to, let's try that. Should see some slides. Are we good?
There you go.
All right, very good. So that first joke just failed miserably because nobody saw the slides, right? So anyway, Hugo will be demonstrating the ECL code. I will be talking about the information behind the code. And we've got a long way to go and a short time to get there, as somebody used to say in that movie Smokey and the Bandit, to show you how old I am. So listen, we're going to first talk about ECL and HPCC systems. And when I was presented the option of doing this workshop, I was asked if, what do you want to do? And I said, well, what are they doing at ODSC? What's the themes? And they said visualization, NLP, machine learning. And I went, good, because ECL does all three of those and much, much more. If you saw the afternoon talk on the whole kit and caboodle, you'll know what that means. So we're going to take you in the first hour through the introduction to ECL, and then a little look at visualization and some data patterns. In our second hour, we'll take a look at the natural language processing, and then our third hour, machine learning. So let me fire up the agenda. For those of you that missed the afternoon session, we're going to have a brief history of HPCC and the architecture. We'll review what Thor and Roxy is. We'll look at the extract, transform, and load process used with ECL in our first hour, and look at built-in data visualization. In our second hour, we'll take a look at ECL and natural language processing. Hugo's got an excellent presentation on parsing and text vectors that he's going to demonstrate. In our third hour, we'll take a look at machine learning with ECL and a wonderful learning trees tutorial just to show you how to use the machine learning bundles of ECL and how to work with all of the machine learning bundles. In theory, they're pretty much the same once you have the outline done as to what you do with the data, and then training the model, and then assessing the model and predicting the model, et cetera, et cetera. And then at the end of this, a summary and a resources. Now, what I'm going to do, and I think Hugo, maybe you also right now, I'm going to turn off my video screen because I don't want to scare children. You guys know who I am now, and you see that it's a real person talking. So I'm going to turn off my webcam so the real estate of the slides are a little bit easier for you to see. So I'm going to do that right now. Okay.
And I will do the same thing. Yep. And just remind you all, in case you have any questions during Bob's presentation, I will be watching them on the Slack channel. So feel free to post the questions, and we will answer them after each break we will have on this workshop. Okay. So sorry for interrupting, Bob, but that's the key message for them.
Thank you, Hugo. And if some of you recognize his accent, Hugo comes from, he is the king of Waffle House in Atlanta, Georgia. No, seriously, Hugo is broadcasting to us from Sao Paulo, Brazil. And to those of you in California, I am broadcasting to you from South Florida. So this is truly a global workshop. All right, so in my afternoon slide, I talked to everybody about why HPC systems exists, and again, the high performance computing cluster, distributed data, parallel processing platform. So I encourage you to go back and watch that talk. There's a whole bunch of stuff there that I'm just going to go through very quickly here. The idea behind distributed data parallel processing is taking data from multiple sources, pulling it in, processing it in parallel, and coming up with a brand new, smarter data set that got its information from different data sets coming in. So for an example, an insurance company, you might have data from one insurance company, another insurance company, a third insurance company. We pull them all together to get a aggregate look at a particular individual and then can better assess and be more intelligent about their data. Now, HPCC systems, we're going to be using a cluster on the cloud, but then also you can download the Oracle Virtual Box and you can install the virtual machine. We also have hard metal clusters all over the world. And we also, like I mentioned, our cluster that we're working with in this workshop is a cloud cluster that we will have up and running up until, I think, midnight tonight. And then after that, we have another cluster that you can continue to experiment with, or you can start your own cluster on your own laptop and then continue to work with these training exercises. So here is, again, a diagram of how everything works in HPCC. We're going to be doing most of our work in the Thor, well, all of our work in the Thor cluster today. Roxy is going to be the data delivery system. So all of our work is going to be, because we're going to be working with visualization and natural language processing and machine learning, we're going to be working in our data refinery today, our Thor cluster. So our target of our ECL work jobs are going to be targeting Thor. Roxy is the data delivery system that we have to save for another day due to the time that we have. So Thor, a cluster that cleans, transforms, analyzes, profiles your data. Roxy delivers the data. And again, here's another look at HPCC from a layer view. So at the bottom of this slide, you have a Thor cluster and a Roxy cluster, followed by the ECL language that works on that data. And above that, also written in ECL, is our machine learning libraries. And then at the very top, you have all kinds of different services that you can connect to connect to the cluster: Spark, visualization tools, ODBC, etc. Here's another slide that I showed earlier this afternoon about ECL. The language is a declarative language, so you tell the system what data do you want to see and not how to do it. So you don't have to worry about memory initialization, garbage collection, cleanup code, anything like that. You just tell the compiler what you want, the compiler optimizes your code, and you are off and running. So Hugo's going to talk about the code today at great length, and we have two different environments that you can work from. If you're working on a Windows platform, I would strongly recommend the ECL IDE. In the Slack channel, I did post a link so you can go to the GitHub and download this while I'm talking. Install the ECL IDE, get ready to go. And if you just want to watch and see what Hugo's doing, that's fine also. But you know where to get the code, you know where to get the resources, and I do hope that our workshop is good enough to interest you into moving forward with this and actually trying it on some of your own data sets. Here we have Visual Studio Code, which also has an ECL language extension. And then for some people that work in things like the Linux world, you can do everything on the command line also by just referencing the ECL executable. All right, so the ECL IDE does all kinds of good stuff that we're going to be taking a look at. Mainly, you write your ECL code, you can get your results in the ECL IDE, you can define definitions, which then are reusable in other ECL work units, and it has all kinds of bells and whistles, saving to XML, saving to a spreadsheet, saving your results to ECL code, and much, 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 much more. Also, we have our ECL Watch. This is a web service. Any browser can load the ECL Watch, and the ECL Watch gives you all kinds of information like cluster status, job information, scheduling, security, and then you always use the base IP address of the cluster followed by the 8010 port if it's not SSL, or the 18010 port if it is SSL. Again, Hugo will demonstrate that to you in his session. So now let's talk about ECL. ECL, again, is a declarative language designed for big data scenarios. Any cluster size of HPCC system, ECL works on it seamlessly. It's got a source-to-source compiler. There is tons of documentation that's available free to download on our HPCC systems website. I would recommend 2 of them right off the bat, the ECL language reference and then the standard library reference will be enough to get you started. And this slide presentation is also available in PDF format in our GitHub repo that is referencing this workshop. All right, in essence, ECL is divided into 2 statements. You have definitions and you have actions. Now, I could tell all of you out there that I am the best bowler in South Florida. That's my declaration. And I could go around declaring it all day. I'm the best bowler in South Florida. But until you see me roll the ball, it's unproven. I could declare it. I can declare it like I could say I'm the best, but I'm not the best until you actually see what happens. So definition declares the data that you want to see, and actions actually go ahead and execute those declarations. Lets you see the definition results, and a lot of actions can be either implicit or explicit. If you say something like output my data, then it's an explicit action. If you say my data, which is just a definition name, the compiler will look at it and say, well, that's a record set. You haven't really told me that you want to output it, but since you're not doing anything else here, I'm going to go ahead and do this action for you. So many things happen automatically in ECL, make your life a lot easier. All right, little plot twist. You can define a definition as an action to use later. It's because sometimes, well, implicitly all actions are done in parallel, but sometimes you want to do things one at a time. Like first of all, you might want to build a file or output a file, then you want to build an index on that file, which is used in Roxy, and do maybe some kind of sort operation. So you can do that sequentially. And so what we actually can do is you can make an action a definition and then use that later on in another ECL language statement. All right, we are data-centric people. We like using data. As a matter of fact, here is the data types that we have out of the box. String with any length, or if you say no length, it's a variable length string. We have all kinds of different numeric formats, everything from integers and unsigned integers, floating point to BCD decimal types. We've got Boolean data types, sets of data, sets of elements, and then probably the 2 important data structures are record structures and data sets. Data sets is the actual data that you're working with. A record structure is the mapping of your data, how you want the data to be presented in your ECL output. All right, some other important minutia. ECL, thankfully, is case insensitive. White spaces are ignored. Strings, you put quotes around, single quotes, semicolon ends the line of an ECL statement. It uses C++ Java style commenting. The definition operator of ECL is a : =. Equality is equal. There's 2 ways to say not equal. Definitions can be defined only once. And it's a single pass code parser, which means that you cannot forward reference definitions. And those definitions contribute to a result that are actually compiled and used. And finally, there are no loop structures, right? So we're going to be talking about how do we process a data set? How do we start at the first record of a data set, go to the last record of a data set, and how do we process all the records in between? We don't use loops. We use something that's a lot more compact and a lot more, well, in my opinion, a lot more intuitive. All right, so records and data sets. Here is a record structure. It's a structure because you see the word end here, and you start with the word record. There's no semicolon there. You have the word end with the semicolon saying that's the end of my structure. Inside this record structure, you have a data type and a field name, a data type and a field name, and so on. So the data type can be an integer, it could be a string, it could be a Boolean, it could be any of those data types that we showed on that previous slide. What they're showing you below this is a way of doing an inline record structure. So the record name gets replaced with curly braces, and the record and the end statement get replaced with the curly braces, and then your individual fields are separated by commas instead of separated by semicolons. Now, list of data types and their definition names are shown here, but then nothing really comes into motion until you define the data set for that record. In other words, a record would be kind of like a declaration. This is my data that I'm declaring, but then where does that data live? Well, that data is going to live on your HPCC cluster. So the first thing you tell the dataset statement is the name of the file. Then you point back to the record structure and say, how do I want this file rendered in my HPCC output? What record structure do I want to use? And look at the file types we have available. You have fixed length raw records they're mainly fixed length, but you can also have variable length Thor records or flat files. Delimited data, comma delimited, tab delimited, no delimited. You can parse free-form text, anything you want. You can declare a data set as a JSON file, you can declare it as an XML file, or you can use a pipe command that calls a third-party program that converts it into some kind of, from one format into one of these other formats that are shown here. In other words, you could take a PowerPoint file, spray it to the cluster, run a pipe command that parses through the PowerPoint file and converts it into a comma separated value file, CSV file, or what we like to call a delimited file. So that's records and data sets. Here's some code on filters. Every data set can be filtered with a Boolean expression following the data set. So the Boolean expression is, is it raining outside, true or false? It's either raining or it's not raining. In a data set, you might say, is this person in the state of Florida or are they not in the state of Florida? If they are in the state of Florida, go get the record. If they're not in the state of Florida, reject the record. So this is how we work in ECL by filtering our data. We have a Boolean expression in parentheses that always follows the data set statement or record set that represents the data. If the Boolean expression evaluates to true, we get the record. Now you can also, in the Boolean expression, use logical operators and, or, and not. Also, the tilde can substitute for the word not. Here's the comparison operators. One way to say equal, two ways to say not equal. Of course, all the other standard stuff, less than, equal to, less than or equal to, and so on. And we even have a Perl equivalency comparison if you are into that. All right, so Hugo didn't think I could do it, but I think I did give a good introduction to the ECL language. And so let's right now, I'm going to turn it over to you, Hugo. Hugo's going to fire up the ECL IDE and run through some code examples for you, some fundamental stuff. So over to you, Hugo. I will stop showing my screen. First of all, let me change the presenter. So I will make you the presenter now, and I will stop showing my screen, and then you'll have the ability to show your screen.
Yeah, let me start sharing my screen here. To show my screen, and appreciate if you can tell me whether you can see my screen.
Yep, you're loud and you're looking very good there. If you take your video off, people could see probably more if you want to, but if you want to leave your video on, that's fine.
I think I'm not sharing the correct screen here. Just a second. Sharing.
Yeah, right now I see your Outlook.
Yeah, screen 1. Okay, there you go. Now you should be seeing the GitHub, right?
Yes, sir.
Okay, thank you so much, Bob. And I just turned it on my camera so you guys can actually see we are changing speakers here, and you don't find awkward that you're now you're now listening to a totally different accent. Okay, so yeah, thank you, Bob, so much for giving this very comprehensive and awesome presentation on the platform. So for those who have not had the opportunity to join the demo talk this afternoon, you are now basically up to speed with all the platform functionalities that we covered during that first session. Okay, and now the goal here, or the intent, is to every is a lot of expositive content that Bob will be sharing with us. I will be demonstrating them in a practical perspective. So you are all welcome to join me and follow these steps along with me. If you just want to sit and watch, that's okay, but I will try to go in a slow pace so everyone can have the chance to actually work with the platform, which I think it's a very interesting part of this workshop and a very nice opportunity for all of us. Okay. Okay, so our home base here will be this GitHub repository. So let me just put on the Slack channel for those who are joining us on this session, and I will also post the GitHub address on our main chat window, because this is where we have all the artifacts that we need to run the workshop. Okay, so basically you can download the presentations either from the demo talk or from this workshop. They are all here, and you can either download the code examples, the data files we are going to be using, and even the IDE that Bob just covered on the very initial slides of this presentation. Okay. Very importantly, for those that for one reason or another may not be able to run the practical examples with me today, this repository will remain online, and I'm giving you guys here 2 options for you to keep trying HPCC afterwards. Okay, so after the conference is over, if you want to go back and play with HPCC on your free time, you can either access this playground environment, which is online 24/7. It's actually a cluster running in the internet. Or if you prefer, you can deploy your own virtual machine on your personal laptop or stood up a cluster on AWS. Okay, all those instructions are provided here on this web link that I'm sharing on the repository. Okay, very well. So what is our first step here to set up our environment and start playing with some code? So first of all, we need to make sure you either have the ECL IDE or you have VS Code properly set up. Okay, so like Bob mentioned, 95% of our use base get along with ECL IDE, but if you are a Mac user or a Unix user, you might want to go with the VS Code and apply the ECL extension over it. Okay, so for those willing to join me with the ECL IDE, all you have to do is click on this repository folder, and you will actually have here the option to download the ECL full executable. It has like a couple of megs, if I'm not wrong, about 50 megabytes. And for those willing to join me using VS Code, all you have to do is to download the client tools package, which is about the same size of the ECL IDE, maybe a couple of megabytes smaller than the full IDE. Okay, and once you download those executables, you can just run them and accept the default options. There are not many, settings you can try to get lost. So it's a pretty straightforward installation. You can just accept the defaults, and in 1 or 2 minutes, you will have the IDE installed on your PC. And how do you know you have ECL IDE installed? You can just fire up your Windows Start menu button, and you will see either the ECL IDE icon here, or if you scroll in alphabetical order, you will have an HPCC systems folder with the ECL IDE icon right there. Okay, so I will give like a couple of seconds for those willing to download and execute the installation. In the meantime, I will just go back to our top level of the repository and show you where you can get the code examples. So during this workshop, I will be demonstrating and running couple of code examples, and you can basically download them in 3 different ways. I have all the code examples in raw format right here on the code folder. So those subfolders correspond to each of the practical demonstrations we will have during this workshop. Okay. Or if you prefer, you can just download this .mod file, which is actually a package of code files that are easily imported on the ECL IDE. So if you're running ECL IDE, I recommend you to download the mod file instead of the code files individually, because it will be much more efficient for you to do so. And for those using VS Code, you can basically download the zip file and extract it anywhere you want on your PC. Afterwards, you just launch VS Code and open the folder from where you extracted your files. Okay, very well. And last but not least, if you want to take the data files we are going to use here during this demonstration over to you, you can just download each one of these data files to your local PC. You won't need them today. We have all the files already uploaded to our training cluster, but in case you want to play with them, a couple of days after the workshop, feel free to take them with you. And just FYI, the numbers, you might be wondering what are those numbers at the end of the file names. It was just a nice way Bob had to tell you what is the record length for each of these data sets. And I will show you why that information is important on part 1 of the demonstration. Okay, very well. By now, I assume that those willing to join me already have ECL installed. And the first thing you will see when you launch the ECL IDE for the first time, and let me close my IDE here so you can have a similar experience. So the first time you launch your ECL IDE, you will be prompted for certain login information, okay? So that's where we need to indicate to our IDE what is the cluster we will be using during this workshop, okay? So how do you do that? You basically click here on the preferences button, and you will get this beautiful preferences window where you can specify what is your cluster environment. And let me just show you guys
And you go,
our
while you're doing that, real quick,
ODSC settings.
you go real quick. Also, the first time you've launched the ECL IDE, and if you don't have a configuration, then you will be taken directly to this preferences screen. So you'll bypass the login screen because it'll say you don't have a preference created yet. So it'll immediately take you to the screen if it's the first time ever you've used the ECL IDE on your system.
Very well noted. Yep, thank you, Bob. And for those of you logging in for the first time, this is how your preferences window will look like when you join for the first time. So from here, you can basically click here on new if you want to create a new preferences file. Let's say here I create a new ODSC entry for me. Okay. Oh, sorry, I cannot use special characters. And all I have to do here is to enter the server name of my cluster. And that's the information we have on this slide over here. And I will hand over to you guys over the chat window as well. Okay. And there you go. That's how you set up your ECL IDE to connect with your cluster. Okay. There are a few options here in case you want to customize your environment. And I will particularly indicate you to select the line numbers checkbox, so you can actually see the numbers on your workspace, the line on your workspace being numbered, so you can easily find and traverse your code. Okay. And then from here, you can just click OK and you will be all set. I would just click cancel because I've already have my own entry set up. And you don't need to provide any login IDs or passwords. I will just ask you to kindly use a login ID which identify yourself, maybe your initials, just so we can, in case needed, see which work units or which jobs belong to you. Okay, and from here, all you have to do is click OK, and it will take you through the main IDE window. Let me just show you how it looked like, and actually let me reset everything right. Okay, so for those of you joining for the first time or opening the ECL IDE for the first time, this is how your layout will look like. Okay, it has quite a comprehensive view of all information you might need for working with ECL, but just like I learned with Bob, I prefer to go with a slightly thin interface. So I basically, first of all, like to work on the left side, so I can just click here on the view button and reset all my main menus on the left side. Okay, so here I have, for instance, my repository. If I don't want to look at the work units right now, we'll get there. I can just close my work units window. Okay, and down here at the bottom, what we have are a couple of informational panels that we will be using to syntax check our code, and also any connectivity type of issues. So most of the time on this workshop, we will be checking syntax, so we can just close this log panel, and we are not going to do any work with searching on our repository, so we can just close those windows on the right as well. And that gives us a much cleaner environment to work with in a first instance. Okay. Very well. So what is left here, folks, is basically a very intuitive type of environment. We don't have many options on the main menu, and we don't need to. Basically, what we will be using throughout this workshop are these buttons over here where we can submit our code, and this button over here where we can syntax check our code. And right now they are read-only because we haven't opened any code yet. Okay, very well. So for those who have downloaded the .mod file, this is how you bring the code into ECL IDE. You can just click on ECL IDE main button on the upper left corner and click open, and that will ask you for a mod file. Okay, you can either open an ECL file if you have one, but in this case we are using the full package of ECL files, the mod file that you just downloaded from the GitHub repository. Okay, and if you have downloaded it in a different place, you just need to find it from where you are. Okay, in my case, I have it here, GitHub, and this is my mod file. Okay, once you click open, it will ask you where you want to import all the code files that we are providing on this workshop. And you can just leave my file selected because that's the main default repository folder, and click OK. Once you do that, all this code will show up on your repository tree on the left. Okay, I won't do that because I've already have the code extracted there, but you just need to click OK, and you will see a small keyword saying finished once all the import is done, and you can just close the pop-up window. Okay. So once you do that, of course, you won't see all these folders I have here on my repository, but you should have this one, the ODSC 2020. Okay. And if you expand it, you should see 4 subfolders. One, call it language overview, which is the content I will be covering on this first part of the workshop. Part 1, part 2, and part 3, which are also code examples we will be covering in subsequent sections of this workshop. Okay. If you are using VS Code, all you have to do is file open folder and search for the location where you extracted your zip files, okay? And you need to make sure you install the ECL extension, just like Bob highlighted at the beginning of this conference, okay? The latest version is 2.6.1. Okay, it's pretty simple. And once you have installed the extension and opened your code repository folder, you will be prompted for creating this launch.json file. Okay, this JSON file, you can just click. It will come up with a default template configuration, but if you need to add more, you can just click in here and select ECL, for instance, play HPCC systems, and it will add you a new configuration section for your launch JSON. Okay. In my case here, I've already have a default configuration for our, conference cluster, and all you have to pass here is actually the IP address for our workshop training cluster. And again, I appreciate if you can identify yourself, not fully, but at least at a certain level where we can distinguish who is owning which work unit. Okay. Okie dokie. So here we are with all the environment set up. There is nothing else left for us to set up. And I will invite you all to open our first ECL file in our ECL IDE. So you can just select here this bwr_hello.ecl file, and you can just double click on it. And there you go. You will have the code opened on your ECL IDE window. Okay. So you might also notice that our main menu buttons are now activated, so you can use them. And before we do that, let's take a look at this code example in more details, starting with what we have up here on the top. Remembering some of the content that Bob has just shared at the beginning of this workshop, if you include 2 forward slashes, that's how you comment a section of your code. So this content here in green has been commented out, and the other lines are actually real code or active code. And this is the line numbers I was asking you guys to activate when you first set up your IDE. Okay. So let's look at this code and see what's trying to do here. It's the famous hello world. So, but in a declarative way, which is the paradigm for ECL. So what we have here is the definition name, my string, the definition operator that you can read as is defined as, and the definition value, in this case, a string containing the phrase hello world. And at the right here, you have the semicolon indicating the definition terminator. Okay, so that's a basic definition in ECL. But just like Bob mentioned, he's the best bowler in the world. I don't know if it was in the world or only in Florida, but anyway, declaring things doesn't generate any work on our cluster. In order for you to have any tasks, and tasks submitted to our cluster, we call them work units. In order to have a work unit fired up to our cluster, you need to specify an action. And that's what we are doing on line number 7. We are telling the compiler to generate the output action on the myString value definition. So you guys might be wondering or might be guessing already what's going to happen when we submit this code. It will basically output hello world. And we can do this right now. So I will ask you all to do a check syntax first, or a syntax check. You can just click on this button on the top and it will check if your code syntax is okay. And if it's okay, you will see the no errors message at the bottom of your syntax error panel. And that leads you to the next step, which is just submitting your code. You can just click here, submit, or the green button on the upper left, but we will just go with this one. You will see that a submitted expression has shown down here, and right after, it was pretty quick, you should have received a work unit identifier with the timestamp of the time the job was submitted. And you might notice, if you are very fast, you might notice that before this green check mark was shown here, there was a green circle showing that the code was being compiled. And once the code is compiled, executed in the cluster, and it's complete, you should receive this green check mark. And if you just click here, you will see the result of your code on the next window. Okay, so that's the basic workflow for submitting a code file in HPCC. Okay, now that was the basic type of definition. You can always stretch a little bit more, and actually a key feature from ECL is the capability of reutilizing your code. So you might want to start parameterizing things. And one example of making things more efficient, more automated, is by the use of functions. So down here, what we have is the very same hello world, but using a function type of definition. Okay, so how do we do that? I can define a definition, call it suffix with a string word. Okay, and then I can define a function. A function in ECL is nothing but a definition that takes parameters. Okay, in this case, my function is called add suffix, and I'm passing prefix as a string parameter. Okay, and prefix will be concatenated with an empty space plus my suffix definition, which has been defined on row number 11. Okay, and then I can call my function on row 14, passing hello as my prefix parameter, calling my function, and you guys might be wondering what's going to happen here. I'm concatenating hello with an empty space plus suffix value, which is world. And again, I will have my output being composed by hello world expression. And how do you do that? You don't need to submit this code again, because since you have two output declarations on the same code file, you will see two result tabs on your work unit. So if you switch over to result 2, you will see hello world as well. Okay. Okay, so that was the very basic definition in ECL, and we also look at a function type of definition. Now, in a day-to-day basis, if you're going to work with HPCC, most of the time you will actually be working with data sets, right? That's why most of you probably are here to work with big data. So I'm going to show you in a practical way how the record structures and the data sets are declared in ECL. Bob has already showed you a couple of elements from the record structure and from a data set, but here I'm going to show you in a real code example how those things get together. So if you guys now open this PWR record and dataset.ecl file, what we will see here is a actual record structure and a data set definition. Okay, so how do we read that? So every time you guys see a record keyword, what you have next to it are the labels and the types of the fields of your data set. So here I will be working with a data set that has 3 fields, a field labeled ID, another field labeled as name, and a third field labeled as zip code. And the type of data contained on each of those fields is listed on the left side. So I will have a number and signed for as the ID, a string with 40 bytes as name, and a string with 5 bytes as the zip code. So that's how my data will look like. Now, defining a record structure doesn't do anything with your data. You need to tie your record structure with your logical data set, with your logical file. So you do that using a data set declaration. So here, basically, I'm telling the compiler that the logical file residing on the cluster labeled person file has the record structure defined on starting on line number 2 of this code, and it's a delimited file, a flat file. Okay, so those are the 2 key pieces you are going to be utilizing on your day-to-day basis with ECL. Like Bob used to say, is our bread and butter from a code perspective, I guess. And okay, so now that I have defined my data set, how do I visualize or get a first view of my data set? And guess what? Again, we are going to use the output action. And as a parameter to my output action, I'm passing my data set definition, person data. And as we start working with more data, it might become interesting for you to label your result tabs as well. Instead of seeing result 1, result 2, result 3, you might want to label your result tabs so they are more meaningful. So here we are just outputting the person sample. That's why we name it the label as person sample. Okay. So if we just submit this code like we did with the previous one, we will get our code submitted, and there you go. Our work unit has just completed. And this is where you will see the label now appearing as person sample. Okay, and here it is, the data set we are viewing right now, the person file. We have an ID, unsigned for, a name field, string 40, and a zip code field, string 5. Okay, so that's the basic data set declaration in a very common code structure that you're going to be using on your day-to-day basis working with ECL. Okay. Now, expanding this a little bit further, most of the time after the first injection of data sets in the cluster, you might be wondering or might be wanting to filter your data. You don't want to see all the person data, but you want to filter certain specific persons. And that's where you use the filter structure or the filters, just like Bob has showed us on the first part of this workshop. If you pass a Boolean expression in parentheses right next to your data set definition, this is actually a filter. You are specifying that you want your person data set to be filtered on the zip code field and this is the value you want to be filtered out. Okay, so I'm storing the record, the resulting record set on this one zip definition, and then outputting the one zip definition again using output action. And I'm also labeling my result tab with zip 60505. And I don't need to submit this code again because both outputs were processed once. I just have my zip 60505, and here I have all the persons whose zip code is 60505. They have all been filtered by the third column. Okay, so those are the key and basic definition types that you might need to work on your day-to-day basis. But of course, sometimes you don't just want to look at the data and do some basic filtering. You want to start doing some cross tabulations between fields, and that's also possible in ECL. So if you just open the BWR person by zip file, you can see here that some structures are now becoming familiar. We've already have our record definition starting on row number 2. We have our dataset definition on row number 8, and on row number 10, we have a function called a table, which will actually do a cross table for us. And what is the cross table I'm trying to do here? I'm basically telling the table function to count the group of records sharing the same zip code. And that value will be stored on this field. And I will also have the zip code values on the zip code field. And once I have this logic, I can output the result of my table function. And again, I'm naming or labeling my result tab. And here I'm being a little bit precious because I just don't want to see the tabulation, but I also want to see the tabulation on descending order from the highest value to the lower value. Okay, and that's what the sort operation does, or the sort function does for us. Okay, so if we submit this code, and here it might take a little bit more because it's doing the tabulation, but again, it was pretty seamless. And there you go, a cross tabulation showing how many people we have on that data set on each of the zip codes contained on that data set. So 69 people, or 69 records, where each record represents a person, have a zip code of 37201, and etc. in descending order, right? Very well. But again, a tabulation doesn't mean you're actually transforming your data, which is a very important part of any big data processing organization. And that's where HPCC actually becomes even more efficient and friendly for you, because even complex transform operations become simpler in ECL. And I will just quickly go through the main transform structure we have in ECL, and guess what? It is called a transform. So if we open the BWR transform and project.ecl, you will get a code file like this, where again, you will be seeing some familiar structures already, the record structure and the dataset definition. And by the way, you don't need to declare these things over and over. We're just showing you from the basics, from the beginning. But on the next part of this workshop, you will see how to do that on a much more efficient way, actually reutilizing the code. Okay. And how do I do a transform operation on my data set. Let's say I want to convert all the person names from mixed case to uppercase. Basically, you declare a transform structure. A transform structure transform record structures, and you can specify or control the logic of the transformation. How do you do that? You basically specify what is your output record structure, which in this case is the same as my input record structure. I name my transform function, and here is the core logic. By using self.field name, I can qualify what is the transformation being processed by each dataset field. In this case, I am picking the name field and converting to uppercase using a inbuilt function to ECL. And that's a very nice thing of ECL. Many of the string operations, numeric operations you need to do on a basic transformation operation to standardize your data is all provided in libraries that are already available for you to use them at your own need. Okay, so here I'm just passing the record name field and converting it to uppercase and storing the result on the name field, and everything else is being passed as is. Okay, so here I'm specifying the logic of my transform. I'm defining my transform, but just like defining Bob as the greatest bowler in Florida doesn't actually make anything, you need to add some logic to activate or call the transform function. And even though we don't have a formal loop, what we have is a function called project, which is a iterative type of function which will iterate across your data set and call the transform function, passing one record at a time. Okay, so once I do that, I can just basically output my project result, and I should get at the end of this transformation all of my mixed case person names converted to uppercase. Okay, so here is my original data set with mixed case, and if I click on the next result, I see all the file now is converted to uppercase in a single pass. Okay, and you can scale this up, adding more and more complexity to your transformation, but the basic transform engine is still the transform being invoked either by a project or any other iterative type of function that we have in ECL. And finally, sometimes you might be wondering how, or you might need to work with more than one data set at a time, either because you want to combine them, either because you want to compare them. And that's where you can use a very important function in ECL called join. Okay, so if you open up the bwr join.ecl file, and I will submit while we talk, the join function will basically allow you to work with two data sets at the same time. And let's look at what this join is doing right now. We have here one record set or one data set, person data, with fields ID, name, and zip code. And down here, I have a second data set called zip data with zip, city, and state fields. And I might want to combine these two data sets in the sense that I want to complement or supplement the zip code information from the first file with the city and state information coming from the second file, and combine all of them on a single output record set. Okay, so how do I do that? I basically use join to do this kind of operation. And a join operation is basically defined in the piece of code that I'm showing here. Okay, first of all, I specify the output layout. So how do I want the records on the join data set to be organized. Here I'm specifying that I want ID, name, city, state, and zip code. And then I need to define my transform function, specifying what is the logic of filling those fields. So here I'm telling the transform function that all the fields pertaining to persons, like ID, name, will be coming from the person data set, and all files, all information exclusive to the zip file will be coming from the zip file data set. And then I just need to specify my join operation, listing the two data sets that I want to join, and what is the joining condition between those two data sets. In this case, the zip code from the person data field and the zip file from the zip data set, and call my transform function. After I'm done with the join, I can just output the join result, and there you go. You now have the persons, each record, not only displaying the zip code, but now displaying the city and state information along with it. Okay. So those are the key, operations in ECL. We started from the ground. Just to recap, we started from the ground, from the very first hello world definition. We showed you how to compile this code, how to do a syntax check, how to submit this code, what's the difference between a basic definition that doesn't do anything in the cluster and a real action, which will actually trigger a work unit to the cluster. We showed you the basic record and dataset definitions, which will be your bread and butter for working with datasets. And then we started querying using basic filters, which are basic Boolean definitions that you pass in between parentheses right next to a dataset. Or you can do a cross tabulation using the table function. If you want to do transformation of your data, that's where you can start working with transform functions. And if you want to work with more than one data set simultaneously, you can use join functions on your work. Okay, so that was it. The goal of this language overview was to show you first, how does the syntax looks like in real code examples. Secondly, the functionalities inbuilt in ECL. You can see that the language, it's a high level language. It's very intuitive. And third, it's easy, right? The name of the functions and the way the code is structured makes it easy for you to define what things are, and the compiler will figure out how to do the action you want to do in the best way possible, leveraging the parallel distributed processing platform, which is behind all of this. Okay, very well, Bob, that was it for the code review, the first code review. It took me like a little bit longer than anticipated, but I guess it's now time to talk a little bit more about ETL, ECL, and visualization, right?
Yep, sounds good. So Hugo, if you could just change presenter back to me and stop showing your screen, and I'll show mine.
Yep, let me change presenter to you. There you go.
All right, let me show my screen. And let me know when you see the slides again.
Yeah, I see it already.
All right, fantastic. All right, thank you so much, Hugo. And to everyone out there, we're still scratching the surface. These are the basics of ECL. And yeah, we're going to throw a lot at you in 3 hours. And the next rung of our ladder is going to be data visualization, and as Hugo said, using ETL. Also, I just want to mention at the end of this presentation, we're going to give you some links to some online lessons where you can go back, review this code at your own pace, go through the introduction lessons, go through the advanced ECL lessons, and once again, go through these lessons as fast or as slow as you want to go. And at the completion of these online lessons, we'll even send you a nice digital badge that we just introduced last month to all of our online people. So, and also if you attend one of our remote training classes, same thing. So anyway, Hugo was talking about setting up the IDE. These are just slides that review what he just did. Here was the hello world that he demonstrated. Here is the record and data set example that he showed you. The filter example, transform and project. So these are all in the PDF that we include on the GitHub repo. So again, you can download this and study it at your leisure. And please, if you have any questions, you can email myself or email Hugo and ask any questions regarding ECL. That's what we're here for. So next we're going to talk about, and this is our first real look at ETL and visualization. And after this visualization and Hugo demonstrates his code, we'll take a short break and we'll come back and talk about natural language parsing. Although in the virtual workshop, I know you can get up out of your desktop at any time, and if you need to take care of any kind of business, you can do that. But I like to also give breaks as periodic as possible to keep your attention span going. So after a while, I don't want people to zone out. I want to give you guys a break, let you refresh your beverage and do whatever else you have to do. As a matter of fact, Hugo talking about bread and butter, it's dinner time here where I'm at, so he was making me hungry. All right, so anyway, let's move on to our next topic, and this is called ECL with ETL and then visualization. And once again, this slide I showed in the earlier afternoon demo talk, where data comes in. Thor will profile and clean your data using ECL tools, standardize the data to a common record format that is already existing on our cluster, and then those entities can be then linked together into a composite fusion of data, which then gives us something that our data scientists called the data donut. And this data donut, this sweet spot, then can be delivered to our customer via Roxy. So everything you see on the right side of that spot there, the sweet spot in green, is our Roxy data delivery. Both of them use ECL. So once you learn ECL, you are a Thor programmer and you are a Roxy developer. Now, Hugo's going to demonstrate the operation of moving data from the landing zone over to your cluster. We're going to be working with a property data set in the next couple of sessions here. So we're going to spray some property data, and then we're going to run a quick cross-tabulation report that Hugo demonstrated earlier. And then we're going to actually show you the built-in visualization that is bundled automatically with ECL without you having to go to some kind of external visualization source, although you can. But ECL is built in automatically to have some pretty powerful visualization tools that you can distribute to your customer or to other developers or to your manager for that matter. So once again, this slide I talked about this afternoon, we start from the landing zone. You're going to be taking a fixed length file, and then using the ECL watch, you're going to be dividing this property file into 3 separate parts, or if you had a 5-node cluster, 5 separate parts. If you had a 10-node cluster, 10 parts, and so on. And then we're going to treat all of these parts as a single logical file in our dataset statement in ECL. So that's going to be the first thing you're going to do. Now we're going to be talking about profiling the data. And once again, we are really adamant about the quality of our data in LexisNexis and using ECL. So we have a lot of different ways that we can clean our data, verify our data, profile our data. And a lot of it now is just pretty much automatic. You don't have to write one line of code to do that. So the first method is called data patterns. It's built into the ECL watch under a tab called data patterns for whatever file you want to profile. You then click on the button called analyze, and you get a complete, comprehensive, detailed report about that particular ECL file. All right, and there's 3 ways to use data patterns. The first one, again, is the ECL Watch. Second one is a bundle, which you can go out and download. And the third one is our standard library reference. There's a call that's called std.datapatterns and a function called profile. So you simply say std.datapatterns.profile and the name of your file, and you can do it in ECL code, or you can do it using the web service ECL Watch. Here's the kind of report that you get. So once again, this on the upper left-hand corner here, you see ECL that's running a data pattern profile, datapatterns.profile on the 3rd line. On the right, just a couple of requirements. The file that you're profiling needs to have a record structure that's stored in ECL Watch, which most of them do. If not, it's a simple output statement that will generate the record structure for you, and then you can profile that new file that you output. So Hugo will show you a little bit about that. And that's it. So data patterns, that's one part of the thing. Now, cross-tabulation reports are also ways of analyzing data. And there's many, many, many other ways that we use ECL to analyze data, but we decided to cut to the chase and come up with a single source of profiling and analysis. And we liked it so much, we give you 3 different ways to do it, and it's called data patterns. Built into the ECL IDE, built into ECL Watch, open source, free of charge. All right, now let's talk about the built-in visualization that comes with HPCC systems. Once again, your data can be visualized in 3 different ways. Number 1, there's a chart tool in something called the ECL Playground, which is part of ECL Watch. The ECL Playground sounds it does exactly what it sounds like. It's got sample code that's ready to run, and you can study things that Hugo talked about, like simple filters and joins and projects. All of that is contained inside the ECL Playground. And the ECL Playground has a chart tool. So there's some chart examples that are in the ECL Playground that instantly give you visualization of your data. We have a Visualize tab. For every ECL job that you have, you can visualize every single piece of data that you output to the cluster. And then finally, you can take advantage of our ECL Visualizer bundle. You can call a number of different chart tools, and then the bundle will automatically render that visualization in a built-in resources tab, which is also located in the ECL Watch. And that you can distribute. You can send the URL to a customer, another developer, a manager, just to show them what your data looks like visually. And of course, you can call out to other types of visualization tools using service structures and such, but you know, we're getting pretty good with our built-in visualization tools, and I'm just going to show you the number of graphs that you can have here. All right, here's how easy it is to install the Visualizer bundle. You simply go out to your Client Tools bin folder, you run the bundle ECL executable with the bundle attribute, and then the install command, and then the location of where the Visualizer bundle is located on GitHub, and you're there. All right, so real quickly, there's some base stuff for visualization that's used by other types of graphs. You have bubble graphs, pie charts, summary charts, radial bar, word clouds. You can do scatter graphs, an hex bin format, a contour format, multi-dimensional area, bar, column, line, radar, scatter, step charts. Network, relational, like you can have a bubble graph where you can have, here is my person's file, and it's related to this data called my vehicles file, that's related to a licensing file, and it will draw a visual chart based on the relationship between the entities. And then we have the very popular geospatial graphs, US states, US counties, Euro, of Ireland and Great Britain. Now, here's the beautiful thing. Once you install the visualizer bundle, you simply reference a built-in function called __test, calling the main module of that visualizer, like as you see at the top there, choropleth module, relational module, and then you call the test function, and your graphs, sample graphs will automatically be generated for you, so you can shop around. You can say, I want to see what this graph looks like. What does this graph look like? And so on. So you have these test functions that you can run that will allow you to test your system and actually view the graphs that we render for you in the visualizer bundle. All right, here's how simple it is to use the visualizer bundle. After you've installed it, here I've got a simple inline data set, which is a data set that's created in memory. We output the inline data set and we call the named attribute called vispy, and then the visualizer looks for that named ID of the output. So we put it as the third parameter of our pie chart called vispy, and you'll get a pie chart. And what you do to see the pie chart is you go into the resources tab of this generated work unit, and it will simply show you the graph. I think Hugo's going to show you a US chloropleth based on the property data, and he'll show you exactly how easy it is and how simple it is to do it. And so with that, I'm going to turn it back over to Hugo. Hugo, you can then show them the visualization. When you're finished, we'll take a short 10-minute break. And if you have any questions, please, please, please put it in the Slack channel, and we are here to help you and answer anything that you might have. So I'm going to stop showing my screen. I'm going to change presenter back over to Hugo. Where are you, Hugo? Okay.
Yeah, I'm here. Can you see me?
Yeah, I'm just trying to make you a presenter, but looks like you're already a presenter now. Did you make yourself a presenter?
Yeah.
All right, so I stopped showing my screen.
I think so. Thank you.
Yeah, there you are, and I can see you now, and I can see your ECL IDE.
Okay.
So take it away.
Perfect. Thank you so much, Bob. And thank you for introducing most of the visualization features in ECL, or HPCC actually. So on this second part of the code review, actually the first part, the previous one was more like a language overview to give you the basis. So now you can more easily work with sample codes and understand what's going on, okay? So now we will be talking about how we can visualize data in HPCC. But before visualizing the data, you might be wondering as well, how does the data get there actually, right? So far during the language overview, we have just seen what is the structure of the code, how the ECL IDE allows me to develop my code and submit my code. But actually, we never talk about how to get the data into the platform, which is what we're going to do now, okay? So I will kindly ask you all to open your favorite browser and type in the address that was shared at the beginning of the session, but I will just share it once again with the full HTTP address, where you can actually access the ECL Watch interface, which you recall was one of the HPCC interfaces that Bob has presented at the beginning of this workshop. So we just don't have the ECL IDE interface where the developers actually program their code, but we do have a web interface where you can, among other things, manage your workload and manage your files, okay? So once you have typed in the address that I just provided on your browser, you should see a landing page like this, okay? And I will quickly ask you to go through to this Files button on the top, okay? Files button is the module or the area on ECL Watch where we ingest files from the external world into the platform. So I will ask you also to look at the landing zones tab under the files menu, which is where we have our let's call open door to the external world. Okay, here is where your basic raw data files are first uploaded. And we've already included the files here for you guys, but in case you want to upload additional files, all you have to do is click on this upload button, and it will ask you to inform what is the file, or where is the file you want to upload. And once you click open, you will see the file listed here. Okay, but in our case, again, the file is already here, and I will ask you all to start spraying the property file. That's the data set we are going to be utilizing on our visualization exercise. Okay, so once you select the property file, you have several different spray operations that Bob has illustrated during the slide presentation. And in this particular case, we are working with a fixed length record file. And how do I know that? Well, first of all, we created the file, but if you don't have that kind of control, you can always click on this hex previewer right here and take a peek on how does your file look like. Okay, so in this case, the property file is a fixed length file, and you can control the width of the record using this radio button over here, and you can slowly see how the records get aligned between each record. See, it's almost there, but then it becomes a little bit fuzzy again, and you can try, in case you don't have any control of the data being ingested, and play around with these values until you start seeing some patterns being established, like here, almost there. There you go. We finally have a record structure, or let's say a record length of 154, and I can see some numbers, some names, information that tells me I have the proper record structure. So it's just a nice for you guys to inspect your raw data files. But going back to the landing zone area, I will ask you to select the fixed spray, because we're talking about a fixed length record, as you could see on the previous slide or the previous panel. And I will ask you to include or name your files with something that makes it distinguishable between all of you. In this case over here, I will just use workshop, column ODSC West 2020, column my 3 initials. Okay, I could use any other structure. I'm just passing the target scope, which will actually be the folder structure mimicked on the cluster side. I will show you that in a second. And just for consistency, we are using, or we are renaming our data set to property to make it more human readable. We don't need the record length information in the file name no more. And here is where you specify your record length value, 154. Okay, so I will just click overwrite here because I might have already a file named like that. And I will click spray down here, and that will actually launch a new work unit, a new DFU work unit, which will control my spray operation. It was pretty fast already. You can see on this progress bar here, 100%. So all my files have been, my entire data set has been, and I can see here parts have been partitioned. 8 parts, because I have a 8 node cluster in this case. And here is the directory, the target directory information I just told you guys. Workshop, ODSC West 2020, my initials. That folder structure or directory structure comes from my logical name, or the portion of the scope of my logical name. Okay. If you want to take a look of how your data was partitioned, you can always click target, and you have this tab here, file parts, which will show you for each IP address representing a node on your cluster, how many bytes were sprayed from the original file on that particular node. And you can see here that the spray operation tries to more or less uniformly distribute the data across the nodes. Of course, it is not always possible because the spray operation doesn't break any records in the middle. It always looks at the record terminator to determine where to break or partition your original data set. So that might result in slightly different byte size in between nodes. But one very nice thing I want to mention here is that you might think you are seeing everything in double here, and that's actually true. You can see that for each part of my data set that now has been sprayed, I have an original file and a copy, and they are residing on different IP addresses. That's because HPCC has a inbuilt data redundancy type of feature, where if one of your nodes for some reason has a failure, you can quickly restore the data from the next node, which retains a copy of your original data from the primary node. So it's like a inbuilt redundancy type of functionality that comes right away when you deploy the platform. Okay. And how do you see your data actually in the cluster? That's when you can go back to the logical file tab, and you can see here on this window all the logical files currently sprayed to the cluster. Okay, I can see, for instance, here the property file that we just sprayed and all the other files from other users as well. Okay, so now let's switch over to our ECL IDE, because if we want to visualize the data, or if we want to do anything with the data, we need to establish some code around it, right? And the first thing we need to do, like we saw in the language overview, is to define the data set. And to define a data set, I need to define the record structure of that data set. And that's basically what we are doing on the part 1 folder right here, when you guys right click on the file property.ecl file. Okay, file property.ecl file, it is actually a module file, and it contains two attributes: the record structure and the dataset declaration. And why did I encapsulate those two things into a module? That's because we will start exercising the reutilization feature or characteristic of ECL as a declarative language. Every time I export something on my code file, I am making it available to other code files in my repository. But each ECL definition file should have a main export. And if I want to export more than one attribute, that's when I use a module. So my module becomes my main export, and I reference the layout and the dataset by fully referencing my module name. Some of you might think it as a class in other programming languages, okay? But there you go, this is my record structure. I have person ID, property ID, house number, city, state, and zip, some attributes from the properties like value, the size of the property, how many bedrooms, etc. And this is where I'm referencing my logical file that we just inspected on the ECL Watch Files tab. Okay, and my dataset declaration is associating this logical file to the layout being defined right here. Okay, so declaring something doesn't mean we are actually doing something in the cluster. So that's why we have this PWR viewData.ecl file, which will actually trigger all the actions we want to exercise when viewing this data. Okay, and now we are starting to establish our code repository in a more ECL way of developing code. So here I have a file property that contains all the attributes for my data set. And if I want to visualize this data, I now establish a ECL file, call it BWR or Builder Windowable Runnable file, which only contains actions. Okay. So how do I reference my property file now? If I exported something in an ECL definition file, I can import the attributes using import keyword. And the dollar here is just a shortcut to indicate I'm importing everything being exported on my module or my repository folder, the current repository folder. And once I do that, I can basically output as usual, passing a full qualified path to my data set. Dollar file property dot file, which if you recall was file property file. Okay, full qualified definition of the file data set. And you can just submit this code and you will see here a brief overview of your data set. Remember, person ID, property ID, house number suffix, street type, etc. And this first visualization, if you think from an ETL pipeline perspective, it's a very important first step for you to assessing the quality of your data. You might notice, for instance, that the house number suffix is all empty. Is that supposed to be like that? Or does that indicate an error? So it's a first look at how good or how bad my data is before I start actually processing it for a data analysis type of activity later on. So this is a quick overview. So the output by default will just show you the first 100 records of your data set. So if you scroll down, you will notice that the first 100 records have been displayed, because the intent of a output action is just to store this output in memory so you can easily see it. If you want to see all the records from your data set, you will need to output the data set to a disk file. So how do you do that? Using the very same output action, the very same data set name, but now passing a logical file name where your data set will be stored. But now it will be stored. You might notice here I have an empty space between commas, and that's where I'm telling the output to use now the record structure that has been defined for the property file and save that as a metadata on my logical file name. Okay, and how does that help me? If we look at the second tab here, the disk output, an output that has not been only on my work unit, but it's also on disk, the content at a first sight is basically the same. Okay, but if you scroll down all the way to the bottom, you will see that now all the 166,758 records have been outputted. They are now on disk. Okay, and once the data is on disk with a record structure associated to it, then additional power comes to your hand. And what is the additional power I'm talking about is the data patterns report that Bob just showed you on the slide presentation a few minutes ago. So remember that we have now saved our data set on a logical file. That's the logical file name. And if you click on the logical file name and click on the data patterns tab, you can now see a data patterns report, or you can execute the data patterns report if you will. It might take a few seconds depending on the size of your data, but after the data patterns report is run, this is how you will get on your ECL window, ECL Watch window, a dashboard, a pretty nice dashboard with several details about your data. For instance, what is the percentage of filled fields or filled records? In this case, 100%, which is good. It will tell you the cardinality of the field, if that's a matter for you at this first point in time. But most interesting, in my opinion, is also the type of optimization you can do on your data structure. For instance, in the house number field, that field is currently defined as a string 10 type of value. But here I'm taking 10 bytes to store each value from each record. The data patterns report has told me that this field can be accommodated on a unsigned 2 field, only 2 bytes. So I am saving 8 bytes per record if I do this optimization on my field definition. And it might not look that much on a first sight, but when we're talking about big data, billions of records, that number can become pretty interesting, especially when we think about transformation performance point of view. Okay, so that's what we call a profiled view. So you had the raw data view directly from the ECL IDE, the first 100 records. If you output the data set to disk, you now have a profiled view, much more. But you might have a different need. You might have a marketing view need. And what do I mean by marketing view need? You might be interested, for instance, looking at this data set, see how we have the total value fields here, and see how we have the address information of those properties, including a street type. According to my colleague Bob Foreman, there is a legend in US that if you have a property on a street type starting with CT, PL, SEER, those are street types, small street types like plaza, place, lane, where usually you have properties from rich people. I think I got that right. And if you're someone working in marketing, you might be interested in knowing what is the aggregate total value of properties that are located on small streets. That's supposing that that's your view need. How do you do that? How do you construct a query that at first sight seems to be complex? And I can show you it's pretty easy, again, building on top of your basic blocks of ECL code. And most of your queries on HPCC or ECL, no matter how complex they are, can be thought of 3 main steps. First of all, define the data you need to work with. We'll get there in a second. Secondly, define your filtering conditions. And third, filter and aggregate your data. Those are very important steps, 3 basic steps you can use on a declarative programming language to build complex queries. So in this case, what is the working data set in fields? I will be working with the property file, the total value field, and the SS valued field. And what are my filter conditions? I want to filter the street type for this set of values. Remember, lane, way, place. And I want to extract the highest value from those properties. And remember, I have 2 value fields on my data set, a total value, which actually reflects the value of that property, and a assessed value with, you know, some real estate company can establish for my property as a estimative. So I'm looking at the total being the biggest between assessed and total, okay? So those are my filtering conditions. And then once I define my Boolean conditions, my filter conditions, I just apply them on my data set. Here is my property data set. I want every data set whose street type is contained on that set and whose total value is the highest between total and assessed. And I just sum up the values using the sum function. I also have here some logic in case there are no small properties to throw a -9, but that's optional. It's just a nice thing to have. In a first site, you can just go with the sum function to get your total aggregated values from all properties residing on small streets. And just for you, you might be curious about it. How do I run that query? I just reference the definition name containing the query and pass it as a output action, just like we did for outputting my data set. And you might be curious about it. It's about 5 billion monies, $4.5 billion, let's suppose, the total aggregated value of the properties residing on small streets, which tells me Bob is probably right when saying that people living on small streets are richer. Okay. And finally, you might be interested on visual data. You don't want to see only the values, no matter how complex they are. And I'm showing here an easy way to do visualization. Just output some cross tabulation. In this case, we are tabulating property price per state. And once you do that, of course, you will have your tabulation right here, each state and the average value and the number of properties from that state. But you don't want to look at the numbers precisely. You want to see a visual representation of that number. That's when you can go back to your ECL watch, and I haven't talked about it yet, but that's an interesting time to talk about. You see this little gear over here. If you click on that image, you will see all the work units, all the jobs you have submitted, or everyone connected to this cluster has submitted so far. And if we click on that particular work unit where we did the crosstab report, you can go here on output and select your crosstab result. And notice here we have a visualize button. If you click on that visualize button, you will have a series of inbuilt graphs that you can use right away to visualize your data, such as this column chart. But you might have interesting graphs like the one showing your data per state, right? Since we are talking about property price per state. And here, depending on how you are viewing this data, there is a different degree of color for each value. But since the values are pretty close to each other, see, like Colorado is 117, Wyoming is 105, they are close together. But I think the winner here was Iowa with $133,000 as an average price for properties. Not sure if that makes sense from a real point of view. This is all fictitious data, but that's how you can get some visualization right out your code without too many complexities. Bob has also mentioned about the playground. So if you take a look here at the playground tab, you do have some pre-built visualization that you can leverage if you have, like, fairly small code. And why I'm saying that, because in the playground you have an area where you can actually paste your code, submit the job, and look at the results. So let me take, for instance, this piece of code. I basically doing a output of a series of numbers representing zip codes and states. If I submit this job, it might take some seconds because it's going through my internet connection. And you can see here the result of that work unit. And if you click on this diagram bar or diagram icon right here, you again have a series of pre-built visualizations. And in this case, let me just zoom in a little bit, is the visualization of US counties with the numbers being provided by that data set. Okay, and of course, if you leave the playground area, you will lose this code. So it's actually just a playground area, as the name implies. Okay, but to complete, and this is where things become even more interesting, if you have a real specific type of visualization need, you can then look for our visualization bundle. And visualization bundle will give you many other options for visualizing the data. And how do you get the visualization bundle? Bob has showed you briefly on the slides, and I can show you here on a DOS window. How do you actually run the ECL bundle install command, and you point to our GitHub repository where you can get the visualizer bundle, okay? And you just click enter, again, being a local admin from your PC, and the bundle will install right away. And from that point onwards, if you look at your ECL IDE and look at this bundles folder down here, you should have a visualizer or different ECL files for each bundle that you install. And that's a very nice thing about HPCC. You can start shopping things without paying anything for it as you need. So if you need more visualization, just install the visualizer bundle. Okay. And how does that give you more power? That actually enables you to control what kind of visualizations you want to see. So real quick here, remember that Bob has mentioned several different types of graphs during his slide presentation. And here I'm calling a few of them, like the multi-D, the 2D pie, the multi-D bar, and I'm basically outputting, different data sets using different bundles. And how those bundles became available into my code, just because I'm now importing the visualizer bundle on my code. Okay, and if I submit that code and go back to the ECL Watch interface, look at my work units. There you go, HPCC Viz sample dashboard, and click on it. Now I can go over to this resources tab, and once I click on the resources tab, it will build all the graphs that I have selected or defined on my ECL code. The multi-D bars, the 2D pie chart, and even dynamic graphs like this one down here. This is all coming with the visualizer bundle, and you can include, you can change the properties, the colors, all within ECL Watch. Okay, so that's pretty much it on visualization. I wanted to give you guys a broad overview from very basic raw visualization, just looking at first time at your raw data, inspecting for any critical quality issues. If you want to expand, you can use data patterns, start doing your histograms for your data. If you want to do marketing way, you can start building complex queries using building blocks on ECL code. And if you want to visualize data, you have pre-inbuilt visualization. But if you have specific visualization needs, remember you have the visualization bundle, which will give you much more visualization power to your hands. Okay, so that's it for this second code demonstration. I guess now it's a good time for our break, right, Bob?
Actually, Hugo, we're going to go press on to NLP stuff because we are running short on time right now. So I'm going to jump through that first break. We're going to go right into NLP. Can you hear me okay?
Yep. Mm-hmm.
Okay. I don't know if it's just me or if it's everybody, but in some of your demonstration, you've been breaking up audio-wise. So I want to ask you to do something. During my presentation, if you could go ahead and just close down any apps that you don't need or use, like VS Code. Obviously, you're not going to go back there too much. You can close that up and close, like leave your IDE open and maybe your browser for ECL Watch. But we'll see if maybe if you reduce your resources, maybe your audio will, because a lot of times it was trying to catch up and buffer, and we didn't lose anything that you were saying, but I did. It was getting a little choppy. And it could be your internet. It could be just that you had too many apps open. So also one other tip, and this only happens, by the way, people, when you're presenting, when you're working on a day-to-day basis in the IDE, everything is crisp and fast. And it's just that because we're going, here is Hugo demonstrating code from Brazil that's contacting a cluster in the United States, which is contacting GoToWebinar in California, and back and forth and back and forth. And that's why we're getting a little bit of a buffering issue. But Hugo, for your next demonstration and the machine learning demonstration, go ahead and pre-compile everything while I'm talking so that everything is already done and ready to go if you haven't done so already. And we'll see if your audio can improve in the next session. But everything else is great. Well done, sir. Well done. And if you want to give me back the, let's see,
sure.
presenter, here I am. I'll do it. I think I can do it.
Yep.
And
there you go.
Screen. And let's get on to our second phase. So that first phase was ECL fundamentals and visualization. And Hugo, can you see my slides okay?
Yes, I do.
All right. So, and I hope everyone else can too. So, all right, let's go ahead and talk about ECL and natural language parsing. Now, natural language parsing has been around since early releases of ECL. And the person that actually wrote the natural language parsing library is our chief data scientist, David Bayless. So he put together these NLP ECL code constructs, and we knew years and years and years ago that natural language parsing is critical and something that you need to do every day. So we're going to talk about the basic support that ECL has, namely pattern type definitions, the parse pattern, constructing the expressions of the pattern type definitions, then how we render our search of our NLP to our output using one of our built-in ECL parse functions. So let's get started. The process of natural language parsing in ECL, the fundamentals, involve building patterns of interesting text that you're looking for, then applying the parse function to those patterns. And when the parse function finds a match, it will take the result of your search and then shape it into whatever output you want to see. So it works with patterns, and then the parse function, and then the record structure. So just 3 steps: define your patterns, build your parse function, output your parse function to your desired record structure output, or an intermittent transform function on the way to a record structure. All right, So that's it, the big three of NLP. Now let's talk about them. We have patterns. And again, this is like what I like to say, the bread and butter of ECL NLP is the pattern keyword, followed by the name of the pattern that you give it, followed by the parse pattern, which is very similar to regular expressions. We also have the brother of the pattern called a token, but this brother is very similar to the pattern, except the token will stop when it finds a match, where pattern will continue to find alternative matches by default. So the pattern will continue to do a deep search through your free-form text, and your token will find the first match and go, I'm done, go on to the next one. The third type of pattern is called a rule, which simply is used to combine patterns and tokens together to build all patterns. Essentially, that's what it does. So we talk about reusable code in ECL, and some of your parsing ECL work units will have patterns defined, they'll have tokens defined, and then sometimes you might want to combine them. And when you combine them, you can combine them into rules. The parse function will read that rule, and then you can then take your search results and output it to anything that you want. We're going to look at some examples on the slides, and then Hugo has worked very hard to develop a couple of really cool parse pattern examples that he's going to show you very shortly. So anyway, here's just a list of different parsing patterns using regex type of outputs, of constructs. You can simply have one pattern referencing another pattern, and you can do parenthetical grouping within that pattern. You can expand a pattern by just simply putting one pattern after another. You can look for a literal string, of course. These are all fundamental stuffs for NLP. You can look for the first match, the last match in the string, or you can look for any character in a string. You've got repeat patterns. Find a pattern if it's repeating any number of times. And then you can do ranges of repeating patterns. Here is our optional pattern. Okay, I have a movie title and I have the optional, did it go straight to video or did it go straight to Netflix? So you call it an optional pattern. So some movies go to the theater, some movies go straight to DVD, or they might go straight to Netflix. So that's an opt pattern, shorthand of the question mark in regular expression syntax, and both are supported in ECL. By the way, if you're really good with regular expressions, this is going to be a breeze to you working with NLP with ECL. Of course, we support Boolean expressions with patterns. I'm looking for pattern 1 or I'm looking for pattern 2, and the word or can also be substituted for the pipe character. So the regular expression syntax for or, which is a pipe character, is also shorthand for the word or. Now, I don't know how much shorthand you get. You're only saving one character, which is kind of silly, but anyway, it's there. All right, and then this is a good one. A list of patterns in a square bracket followed by comma delimited or comma separated values. You have a comma delimited list of alternate patterns that you're looking for. And I'm going to show you an example of that, like looking for an article like the, a, and, or looking for, I think Hugo's going to show you looking for verbs and adverbs in his example. All right, so there's some more Boolean logic. Look for a pattern of a given length. Validate a pattern if a ECL expression is true. And then, by the way, all parsing is by default case sensitive unless you tell it otherwise. So you can say, well, everything's going to be case sensitive except for this particular part of the pattern. I want that to be case insensitive. I don't care if it's uppercase, lowercase, or mixed case. We have penalties on patterns, which if you have two patterns that you found and the parsing engine needs to make a decision as to which one it selects, if you have a penalty on one of the patterns, it will select the other one. So, and if you have two patterns that have penalties it will always select the penalty of the lowest value, the lowest cost. So the lower the cost, the more higher priority that pattern would have when compared to another pattern with a penalty. Okay, and then again, you can write your own regular expressions by using the word pattern. Don't confuse this with the keyword pattern. You're going to see this in just a moment. So this is our ground zero of parsing, the fox and the hen. And we show you, first of all, some basic patterns using regular expressions. So white space is either space, \T for tab characters, \R for character return, \N for new lines. Here's a regex for all the alpha characters, A through Z and lowercase a through Z. And then a word is any alpha character, one or more. That plus sign after alpha means one or more. Here's a list of patterns, the and Here is just a word, a penalty of 1. And then a not hen pattern, which is give me all the words that are not hen, HEN. Here's some tokens, okay, that are say, well, give me the not hen, but put a penalty on it. And then here's a token and a rule. The token says, well, just a word or article whitespace word. If I find just a word, I'm done. I'm not even going to search for article whitespace word. The rule will continue to search and find the match. And then if it finds both of them, it's going to use the pattern that has the lowest penalty, which in this example will be article whitespace word because that doesn't have a penalty. No hen word does have a penalty. Here is our parse function. Here is our output record structure in an inline format. When I run this code, the token will give me stop at just a word and give me the fox and the hen. And if I run the second output, PS2, it's going to, because of the penalty, if it finds an article in a word, it's going to output that. Otherwise, if it doesn't find an article in a word and is not an article, so it just will return the single word. So you see the difference. Just by changing token and rule, you can get completely different outputs in your parsing. All right, now we have functions that let you take the result of your parsing and format it into Boolean. Did I find it or not? What was the text or what was the Unicode text of the pattern that I found? What was the length of the search result? What was the position of where it found what it was looking for? And then using Tomita parsing, it will return the whole matching row if you specify Tomita parsing in the parse function. All right, whoop, went too fast. There's also pattern references. Let me show you what that is. Here is a parsing pattern of the Internet Movie Database. And the only reason I know that is because it has a word here called actor, and it's got a role, and it's got a movie ranking and age. And so we have a couple of patterns here. And notice we have a pattern in this line pattern called ARB. All right, and now if you take a look at the output of this record structure, this one movie name field is looking for the second instance of ARB. The second instance of ARB. So you look at this line, you go, wait a minute, there's only one ARB in here. Aha, but if you look back at actor and you look at the actor pattern, the actor pattern has an ARB also. So once actor becomes in line with this line pattern, the first ARB is in actor, the second ARB follows actor, and that's going to give us our movie name. And an arbitrary pattern is just give me anything. 0s through 9, A through Z, special characters, blah, blah, blah. All right? So if I wanted to strip out the number from the movie rank, I simply drill down to the number. It will strip out the angle brackets. If I want to just strip out the square brackets from role, I just go to ARB of role. So this is how you can shape your data. The parse function matches, and then the pattern references let you drill down into the pattern and pull out the good stuff. Okay? Now the parse function works just, you know, it's the third part of the trilogy. You've got your parse patterns, you've got your output record structure functions that we looked at, and now here's the parse function. What data set are you reading? What field in that data set do you want to parse? What pattern are you looking for? and what is the record result. And so there's all kinds of flags here. Because running short on time, I really can't go into them in detail, but they actually allow you control your parsing. Once again, case sensitive is the default. So if you want your parsing to be case insensitive, you put the no case word in front of it and you're off and running. You can skip patterns, you can keep only the first X matches and so on. So these are slides that you can look at. You can have your own rules for parsing. So you can write in ECL, or get this. You remember me talking about embedded languages? If you've got a Python NLP algorithm that you want to use in ECL, you can drop it into an ECL file, wrap it around an embed structure, have your Python code dropped in there, and then call it from the parse function using this matched attribute of the parse flag. All right, and the last one I want to show you is David Bayless. Not only is he a data scientist, he's also a biblical scholar, and he likes to, when he writes his parsing functions, he likes to work on the Bible. It's a good free-form text document, and it's free. You can download it for free on a number of different websites. So anyway, the first thing he does is he clears out the easy bits, white spaces, article, the, thou. Because it's case sensitive, he's got both mixed case and lowercase. He's got his name being a regular expression pattern, starting with a capital A through Z, and then either lowercase A through Z or uppercase A through Z, one or more. Now he's got, he builds a name and a title with an optional title pattern. So Bob the Builder, you know, something like that. Then he's got different ways of producing, like you either begot something, or you're the father of somebody, or you're the mother of somebody. If you're produced by somebody, you become the son of or the daughter of somebody. Produces with, normally it's a wife. And then the relation type. So it's got to be one of these, but not any combination of all three. So then his progeny pattern says name and title, relation type, and so on with somebody else. So we parse it. We then output it to a left and a right and a relational. What relation did we have? And then here we are. We have Shechem, the son of Hamor the Hivite, Hamor, the son of Shechem, and then Esau, the wife of Bathsheba. And if you look at this carefully, Hamor the Hivite had an optional pattern there. So the way optional works is it says, okay, give me it with the option and then give it to me without the option. So a lot of times you can get your results and then you can do ECL rollups and aggregate the data together into a common record format. So he used this to do an ancestry tree. And trust me, I've done this on the whole Bible. There's probably 4,000 plus different relationships of names in the Bible. And you can, and this code works for the entire Bible, and it took seconds to parse. Pretty amazing. All right, so that's all I have for natural language parsing. I'm going to turn it back over to Hugo. And Hugo, go ahead and show them what you got with that NLP stuff, all right?
Sure, I will take presenter here, okay?
You got it. Thank you.
And thank you. Let's see, screen monitor 1. Can you please confirm you're seeing my screen now?
Yes, I do. I can see your ECL IDE. Okay. You are fine.
Thank you so much. Okay, folks, so how does all those pieces come together, right? You have seen how many options you have for natural language parsing in ECL. So I'll now give you 2 quick examples on how you can combine all that power and extract some interesting information from your data sets, especially, of course, if they are not totally structured as fixed length files or comma delimited files, right? We are talking about free-form text. And I will ask you to now expand the part 2 folder of your repository, because that's where we are going to take a look at our file reviews ECL file, where we will be seeing the data structure of our new data set. So we are still talking about properties here, okay? But now we have a property ID, a review ID, review date, review ID, name, but most importantly, some review text, some free form text, which we will now parse using some of the features and functionalities for NLP that Bob has just presented, okay? Of course, I have to declare my data set, and I have already sprayed this file for you guys on the ECL Watch. We have been through the spray lesson or demonstration in part 1. This data set is basically a review of that first spray operation. The only difference here is that this is a CSV file and it has a header on the top of the file. So I'm just passing heading 1 to specify that the first row of my data set is actually the titles or the labels of the fields. Okay, so now let's open the BWR raw data file, which is where we will have a single output just to look at the raw input data. Remember, the basic view of any data set starts with a simple output, first 100 records. And if you submit this code, you can see the shape of it, And we're not actually interested on the first few fields because that's pretty much structured data. But take a look at the review text. It can be pretty large, right? And it doesn't have any kind of logical structure. It's just people typing what they think about a certain property, right? But me, as a real estate operator, for instance, or a person looking for a property, either to rent a property or to buy a property, I might be interested on what people are saying about that particular property. Is it like a cute and cozy place, perfect location, nice place to live, or it could be something bad? I don't think I have anything bad right off the view here, but I might be interested about what real people is saying about those properties. So I can use natural language parsing for that, okay? So now I will ask you to open the BWR parse reviews ECL file, which will contain a first attempt or first approach to extract that data. And the key thing for natural language parsing in ECL, that's what I tell people all the time. As the name implies, pattern, you need to look at a certain pattern in the freeform text. And if you think about how people describe the properties, there is always a common type of structure, such as someone was something, right? If we look at properties, let's see, someone was something, what else? The place was really nice, clean, and the most important. See, there is always a standard pattern here where one element is being associated with an adjective, right? And this adjective is usually what you are interested. You want to see if the place is nice, clean, quiet, right? If the neighborhood is nice. So usually the adjective is what you are looking for. How do you translate that into a parsing pattern structure? I can show you real quick here. So think about the way those sentences are formed. In this case, a substantive, a white space, a verb, white space, and one adjective, right? That's the basic pattern of how those people are describing the properties. And I can call this my rule, my complement rule, because usually people use this structure to complement something on a free-form text. And then I can start building or defining the building blocks for that free-form text. Of course, as always, I start with defining what is my dataset file. In this case, file reviews file, okay? But let's start with the pattern and pattern and token definitions. I can define a pattern definition, white space, just passing the white space in between single quotes. I can define a pattern called alpha, which contains basically any regular expression with a small case or uppercase letter, okay? This is the addicting part, I guess. This is what I usually call it, because if you look at the prepositions and adverb, usually sometimes people in between the verbs and the adjective, they want to emphasize something. The place was not just pretty, but it was very pretty. It was much nicer than I thought, and people like to emphasize that. So I can define, for instance, a pattern with an adverb, and I can now start putting some adverbs here, like so, extremely, really nice, very, little, both. And sometimes people want to use more than just one adjective to complement something. So in order to capture those more complex structures, I can also define a preposition like a, the, and, though, both, etc. And etc. is not a preposition, by the way. The verb, that's an interesting part, because when people describe something or complement something, they usually, in English it's pretty easy. In Portuguese or Spanish it's much harder, but in English you have was, wasn't, was not, were, is, isn't, hadn't, etc. Right? So I can be pretty comprehensive here with just few verb structures. And to account for those situations where people want to emphasize the adjective, I can optionally include a preposition and optionally an adverb close to the verb. Okay, so far so good. Let me just clean up my draw a little bit, and then I can define the longer structure. So my substantive, for instance, can be one alphabet letter followed by one or more alphabet letters. That's it. And the token definition is what will actually do the trick here and capture the longest alpha combination, which is usually my substantive. For the adjective, and let me clean up my draw a little bit more, I can be as creative as I want, because an adjective can be just a sequence of 2 or more letters, but can also have another preposition, because people might want to put 2 adjectives on the same sentence. So the place is nice and very familiar, for instance. Let's call it like that. So all these optional structures will be captured because of my rule, the way my rule has been set. Okay, so despite the fact that natural language parsing might be complex or scary at the first sight, when you start thinking at the building blocks, just like ECL always try to imbue on your thinking, start with the building blocks, you can build some powerful natural language parsing logic. And from here, all you have to do is to specify how you want your data to be extracted, or what is the record structure. And in this case, I want to see what's the property ID, what is the substantive, the verb, and the adjective. And then I parse the text using my parse function, specifying my data file, my field to be parsed, my rule and my result record structure. And if I do an output of it, I have a very nice results table like this, where for each property, and I might have more than one complement for a single property, I have, for example, the name of the property owner has a great room. We had, this is the kind of apartment. Kelly was warm. Kelly was a great host. Apartment is in a great location. Okay, let's see. Stay was expected and comfortable. Place was really nice. It was close to everything. And here is a tip for you. If you want to expand more on your analysis, start looking at what comes next to the adjective, and you will start building more and more powerful analysis. Okay, so you can extract all of this data and look at the properties based on the complements the property has received, and then take a better decision about renting or buying that property. Okay, so that was a pretty piece of code for allowing you, and I invite you all to start looking at more adverbs and more adjectives that you can specify here and build some more powerful natural language parsing. Now, what if you want to automate, or what if you want more power on your hands? Because this is more or less a manual approach where you're actually defining the logic. That's where you can start using machine learning. And one of our machine learning bundles for natural language parsing is text vectors. Basically, what text vector does is to parse your natural language text and start putting the words in a vectoral space, where the vector, the dimension of the vector, implies closeness of meaning between words. So for instance, here, dog and cat, even though they don't have the same meaning, they are frequently used on the same context. For instance, a dog is an animal, cat is an animal. I want to buy dog food or cat food. So even though they are different in meaning, in a natural language or free-form text, they are usually close to each other. You can also use them interchangeably. Now, sawmill is a strange word, but it's close to dog, because if you think on a log dog, you can associate that with a sawmill. But a word like piston is usually not used together with dog and cat and sawmill. That's why it's farther from the other words. So you can use vectors learned from your natural language parsing machine learning bundle to establish a text vector space like this. And what's the power you have in your hands? You can start building query engines, more powerful query engines. For instance, someone looks for dog food, but if a place sells dog food, it will probably sell cat food as well. So you can return not only the results matching the dog word, but any other words that, from a vector space point of view, is close in meaning. Okay, so that's also allow you to build some analogies. For instance, if the text vector bundle learns from your training data that Paris in France on that text has a certain vectorial distance, and if you train your text vector model and it finds London in the text, with the same sized vector, it might find UK in England by analogy in using vector sizes. Okay, so those are some of the features you can use with text vectors. And how do you get text vectors? You just install it, as we did with Visualizer. You need to install our machine learning core bundle, and right after the text vectors bundle. Very similar to what we did on the Visualizer bundle. Okay, and just to give you an overview of how or what kind of results can be provided from text vectors, here I have some samples. we provided on that very same review comments text few words, and we asked the bundle to bring what are the closest words in that text. And you can see, for instance, stay, right? Stay was great. Those are the words close in meaning to stay. And neighborhood, friendly, for instance. So even though those are words in a first instance very different from each other, from a meaning perspective, they should be appearing close in the text. And you can expand and use more complex structures. For instance, I provided this text to my model. The apartment was spacious. And I asked the model to bring me what is the closest sentence from all those reviews. And it brought me this, exactly as described it, easy to get in and spacious, wonderful place. The neighborhood was great. If I provide this as an input string to my model, it brought me this sentence, nice, quiet neighborhood. And from analogy perspective, that's where things become pretty scary. If I provide a input string like this to my model, location is too quiet as place is too quiet. So the bundle or the model has learned from my set of freeform text that location and place, even though they are different words, they have similar meaning. And if quiet is an adjective for location, quiet might also be an adjective for place. So this is how you expand and leverage all possible functionalities from natural language parsing when it comes to using HPCC systems and ECL. Pretty powerful, pretty interesting, and it will probably cover the need you have around NLP. Okay, folks, so this is the piece of code also available on the GitHub. Take a look later, play it yourself, and just remembering, as any other machine learning bundle, text vectors is also sensitive to the size of your training data. So the largest your corpus of data, the more precise the results will be, okay, the more interesting. So keep that in mind when playing with text vectors. Okay, Mr. Foreman, I think that was it for natural language parsing, and I guess we are ready for the last part on machine learning, right?
You got it. All right, so go ahead and change presenter back to me, and
okay.
Or maybe I can do it, or maybe you can do it. Let's see, show my screen.
I did it already.
Yep, there we go. And you should see a blank slide then popping up.
Yep.
All right, marvelous. Very well done, Hugo. Thank you. And again, we crossed over from NLP right into machine learning. We have a half hour to go in our workshop, so I'm going to be as quick as I can again, and Hugo will wrap up and show you a nice learning tree tutorial. And listen, we've thrown a lot at you in what seems to be a little bit of time, but this machine learning tutorial is available as an online lesson, and we have our special free training for all the attendees of ODSC West. And so all you have to do is let us know that you're interested in the training, and all of these machine learning examples that we're going to be showing you are available in my machine learning course that we have online, so you can take it 365 days a year. You can wake up Sunday morning, get your favorite beverage, and sit down and relax and enjoy ECL and machine learning. All right, so funny story real quick. We started with going open source in 2011, and we were really proud about it, and we released it to the public, and the first thing the public came back to us and they said, hey, where's your machine learning library? And we went, our machine learning what? So we regrouped, and I think it was February of 2012 where we released our first beta version of our machine learning library. But 8 years later, we've developed a comprehensive and solid, well-tested system of machine learning algorithms that you can take advantage of immediately, and we are in no way satisfied with what we've got. We're working on new algorithms as they come in. I just heard about the, what was it? The Huggy Face Transformers NLP stuff. And we have another developer on our team that's working with NLP++ using, so there's just all kinds of things that are going, and, stay tuned, keep watching our website, and we've got more and more coming. So y'all know what machine learning is. It's a form of artificial intelligence. We in ECL like to divide our machine learning bundles into supervised, unsupervised, and then everything else, which I like to call just deep learning because it's not easily describable. Unsupervised means what it says. It will learn on very little input from the user. Supervised requires a constant interface with the user to improve its model and so on. So just some terminology here, which I'm sure all of you are pretty familiar with. For example, in ECL, we have record structures with fields, and we have another record structure with a target field. The fields that we use to predict the target field are called independent variables. The target value is called a dependent variable. And so both sets combined together, we call that the training set. The encapsulated learning that we use around it is called the model. Each model has a hypothesis regarding the relationship of the independent to the dependent variables. And again, the machine learning's ability to generalize is its hallmark. So an example we like to use here is trees in a forest. We have trees planted on the hill. You've got height, diameter, altitude, rainfall, and age. Well, it's easy to measure a height relatively. It's easier to measure a diameter. Even the altitude with an altimeter can be measured very easily, even rain with a rain gauge, but it's very hard to measure the age of a tree. Other than cutting it down and looking at the rings maybe, or if there's other things I don't know about, but age is kind of the hardest one of these five that you can determine. So learning a model, normally you try to pick the dependent variable as the one that's not easily analyzed by human means or by visual means. And so that becomes our dependent variable. We use height, diameter, altitude, and rainfall as our independent variable. We construct the model, and we then provide insight into the relationships, the inference, and then we map easy to measure observed features to the hard to measure unobserved features. And it's done in a variety of different ways. Now, supervised learning supports two major types of models. You can be quantitative or you can be qualitative. Quantitative is a value, a numerical age of something. Qualitative is a classification, like an oak tree, an elm tree, maple tree, and so on. And it's interesting how they parallel. Normally, quantitative models are called regression. And by the way, the person that's behind a lot of the bundle development, he's a good friend of mine. He's a developer called Roger Dev. And he told me, don't pay any attention to regression, but regression actually has a history. A mathematician back in the 1700s was working with children and their height versus their parents' height. And his theory was as the lineage went on, the child's height would regress or get smaller. That was his theory. It proved to be wrong, of course, but then the term kind of stuck around, that regression. So that's where the term regression actually came from. Qualitative model is called classification. So again, when I talk about something quantitative, I'm normally talking about the regression model. Then I talk about the qualitative model, which is using some form of classification. Okay, so this slide I'll go through real quickly. You have linear models, you have tree models, and then models that can't be explained other models are just not explanatory, so they're put into a different category. We have a bunch of bundles already ready, and I'm just going to go through these very quickly. We have an experimental repository that's a private repo that requires a login of all of our new projects that we're working on. And by the way, gradient boosted trees is already done. I think dimension reduction is also imminent for release. Our embedded language support, you can also call machine learning via an embedded R statement in ECL, or Python. You can call the scikit from an embedded Python. Also, we have in our GNN bundle, we have TensorFlow, which is literally calling Python right from ECL, all right? But then we have our production bundles, fully supported, validation tested, optimized, performance profiled, and you can use them from release to release. So in other words, if I install HPCC version 6.12 and then I install HPCC version 7.10, the bundles that are there will not change. The bundles will still work on whatever platform release that you're having, and bundles will be updated from time to time, but essentially you can use them across different platforms, which is great. And the bundle installer will alert if there's a platform version dependency for a particular bundle, so you're covered. Again, validation tested, optimized. We compare it with other, like Scikit. Like there's some algorithms that we compare with Scikit. We run the Scikit in Python, pure Python, forget ECL for a minute. We get our results and then we say, okay, now let's run our ECL equivalent, and we will not release the bundle until the accuracy of both is the same. So if we get the same result in the Scikit bundle and we get the same result in our ECL bundle, we know it's ready to be released. And that's just one method. All right, so there's the core, which is you install for most of the bundles that you're using. We have parallel block basic linear algebra subsystem, or PB-BLAST for short. Okay, we have linear regression and logistic regression that are bundles that are currently available and well documented, and some of them even have blogs and tutorials that are built in. And in my machine learning course, I have courses on linear regression and PB-BLAST, and soon to be released logistic regression. Okay, we also have support vector machines. We have GLM. We have a bundle available for learning trees. This is the one that we're going to wrap up with, that Hugo's going to show you. GNN, which is one I've done extensive work on, and a lot of our interns too. By the way, our interns are great. We had one intern that did a lot of work with text vectors, and we have another intern who did a lot of work with TensorFlow with the graphical processing units and got some very promising results using HPCC. K-means, DB-scan, unsupervised guys, and then there's one that's kind of stands alone in itself, text vectors, the natural language mathematical treatment of text and words, phrases, and sentences and paragraphs can be organized as vectors, as Hugo was describing. All right, so we're going to be looking at the random forest algorithm because, number one, it's a really good one, the learning trees algorithm, because it's really good for large data sets. It's got a lot of advantages to it, and for the most part, it's very, very accurate when compared to other types of machine learning bundles. And it's really nothing to bark about. So it's one of the easiest algorithms to use. Like I said, assumption about the data distribution, large number of records, nonlinear. It works well with default parameters. So I'm sorry I'm going through a little faster, but we're running short on time. So that's it. So learning trees is the one we're going to showcase for our tutorial to wrap this up. And I'm sorry, Hugo, you got 20 minutes. And little time for questions, but hopefully we will have some. So, by the way, if you missed some of this, remember, like I said, our online course and the Learning Trees tutorial is also available in the online course, available for download from our GitHub that for the workshop. And we're going to do Learning Trees because it's one of the easiest ones to use, and it's very flexible, and it also gives you very good results. So without further ado, Hugo, you have the floor for the last 20 minutes, sir.
Thank you so much, Bob. And I will take presenter here, show my screen. There you go. Can you confirm your scene now? My ECL IDE.
Yes, you are good. I can see you loud and clear.
Thank you so much. So just to wrap up this presentation, guys, this is a brief overview of how you can implement machine learning or make usage of machine learning bundle, still processing that same property data set that we saw, or that we start working at the beginning of the session, spraying from the ground zero. And what we will do here is basically look at the values of this property. Remember, we have total value and assessed value. We will look at total value field, and we'll try to train a model using learning trees and see how good that model can predict the property values based on the property attributes. And we will just look at the numeric attributes for the time being, from the perspective that we are, first of all, try to use regression and then classification capabilities of the learning trees bundle. Okay, so as a prerequisite for this tutorial, of course, you need to go back and install the learning trees bundle, and I can show you real quick here how you can do that. Remember to install your machine learning core as we did, and then your learning trees bundle for the usage of learning trees machine learning algorithm. Okay, so first of all, you need to prepare your data. So if you open your part 3 folder, you can go to prep 1 and actually see how to prepare your data. Remember, you can use data patterns, for instance, to look at any noise on your data, such as empty fields, zero or null fields, and you can clean your data by using a simple filter. Filter all the fields where values could be null or empty. But that's not enough, right? Because when we talk about machine learning, we need to make sure our training data sets and our test data sets does not have any bias in them. And look how easy it is in ECL to randomize your data set. So what we did here, we just added a new field, call it R&D, and then we projected the cleaned property using this clean filter. And remember the transform structure? We just transform this data by adding a new field, call it R&D, and using the random function. The random function will generate random numbers into this field, which we will use later to randomize our sample. And everything else can stay the same except the zip code, which is a string field, and I can convert to a numeric field just to help with the regression. Once I'm done with that, I can sort my data by the random field, and that will randomize my data, eliminating any bias that might become with the raw data. And look how simple it is to extract my training and my test data sets. I can basically request the first 5,000 records on a new format to be my training data, and the next 2,000 records to be my test data. Remember, there is always that suggestion where you can use 70% of your data to train the model and 30% to test. We have much more data than this in big data, but just for the sake of this workshop, we are restricting ourselves to 7,000 records. And where is the record structure for the training and test data sets? Remember, we always define our record structure on your main data file, and this is a simple view of our record structure only with numeric fields. Okay. So with that, I have my prep data, and my prep data will look like this. All the fields and my randomic field at the end. Now I have all my random data ready to be ingested, let's call like that, on my machine learning bundle. The only pre-processing, if you can think of that perspective, is that many machine learning bundles require the data to be not on a data set format like this, where you have fields and records, but they require the data to be on a matrix form, right? So that's why we have machine learning core bundle as a base bundle for helping you with any pre-processing of your training and test data. And the pre-processing we are doing here is basically referencing our train and test data and doing that matrix format conversion using this two-field function, which comes with my machine learning core bundle. So I'm just passing my train data and my test data as inputs and getting my train data and test data in a matrix format. Also, I need to remember that in most regressions, regression algorithms, I need to specify what are my dependent variables and my independent variables. And I can use a simple project and transform to do that. I can filter, for instance, any fields lower than 10. I will show you right away why we selected 10 to become my independent train data, and the field number 10 will be my dependent train data. I can relabel that field to become 1 if I want to, just for the sake of visualizing it faster. But the way your data will look like at the end of this pre-processing step is like this. You have now the ID of the property on the second column. You have the number of the independent variable on the third column and the value of those variables, right? So this is my independent train data. My dependent train data will look like this. I have my property ID, my independent value variable, and my independent value. Okay, so that's that's what it takes for you to filter, clean your data, and pre-process your data, like 2 steps to get it ready for your trained model. Now, if you now open BWR train regress or BWR train classify, that's where you can train your model and predict and assess your model. So you will see how simple that is, and this is all the code that there is to it, especially when we are talking about regression. So first of all, I define what will be my learning algorithm, and again, depending on the machine learning bundle that you select to use, there will be extensive documentation specifying which learner you can use. In this case, like Bob has mentioned, we are using regression forest. And once you pick your learning algorithm, you can basically use the get model function. Any machine learning, most of the machine learning bundles will come with the get model function, which will extract your model. In this case, I pass my independent training data and my dependent training data already on the matrix format, and I will get my model. And once I have my model, I can use my predict function, again, a common function across different machine learning bundles. And I pass my model plus my independent test data now. No longer training my model. My model has already been trained. I'm already validating or predicting. And then I can output the predicted values and use the predicted values to test the accuracy of my model. And that's when I will go back to my machine learning core analysis module and look at the accuracy function. Again, a common function to be used across different models. And I pass my predicted values against my real dependent values from my test sample data. And I just output those values. This model will take less than a minute to run, but I already went ahead and run it for you. And here you can see, for instance, what were the predicted values for each property. Those were the property price values estimated using regression, right? And on the next tab, I can see what is the quality or assess the quality of my model. So you can see that my model has explained almost 84% of all the variance from my test data. And it has a root of median square error of 58,000 money, in this case, let's call it dollars. So that's the average deviation from my real value, okay? What if I'm interested in classification? I can look at this PWR file right here and use the same learner from a regression model perspective and select now my classification forest, no longer a regression. And the only thing that is required when working with regression in comparison with classification in comparison to regression, you can still use the same dependent and independent variables already pre-processed, but classification needs to work with discretized data, discretized labels. So again, you can use your machine learning core bundle to pre-process the data to the classification algorithm, just passing here your dependent train and test data. And from this point onwards, everything becomes pretty much the same. Define your learner, as we've already discussed. Get your model passing your independent train data and your dependent train data now discretized. Instead of predicting, classify by using your trained model in your independent test data. And finally, check the accuracy of the predicted classes in comparison to your discretized dependent variables and output that value, okay? So here we are not pretty much interested on the estimated value, but how good the model has classified my properties. So if you click on the results tab, you will see, for instance, that this model has a raw accuracy of 0.0045, pretty small, to be honest, and a power of discretization of 0.004, and a power of discretization extended 0.002. So that means usually, or in average, my classification model has this improved precision in comparison to randomly classifying my properties or picking the most common classification, right? So remember, this is all fictitious data. If you apply it to a real data, you will have significantly different values, right? This was just a demonstration of how you can easily inbuild classification and regression capabilities to your big data processing pipeline. And with that, by concluding, I think this workshop, even though it's a three-hour workshop, has served to demonstrate to you the end-to-end capabilities of HPCC. And that was the key point, showing you from the language overview perspective all over to the machine learning capabilities. And to conclude, I will hand over to Bob, which will show you the ending slides with some more additional resources that you can use. Okay, so back over to you, Bob, for the final wrap up.
All right, Hugo, well done, sir. I know that we had to go a little bit faster near the end there, but you can see my last slide there. Can you see that, Hugo, okay?
Yes.
All right. And for the 10 of you that started with us for the 3 hours and hung with us for the 3 hours, thank you so much for being here with us. My philosophy of training, I've been a trainer for 10 years. My philosophy is I will present the same material to one person or 100 people. It doesn't matter how many people are watching. The point is that we really believe in our system here. It's been driving our business. The revenue and profits that we've had has been great with HPCC. as our technology platform with big data. Here are some useful links to take with you. Again, you can download this PDF right from the GitHub forum, and we've got the links to the machine learning bundles. There's an internship program. If you're interested, you can check out that link. We have a student wiki of some of the projects that some of the students have already done with HPCC. We've got the getting started with HPCC. If you want to go back to that, the online training, that's an important link. That where all the online training is, and we're offering you all of the lessons free of charge. So normally it's just the introduction lessons that are free, but we're giving you, as an attendee of ODSC West, as our gift, we're giving you access to all of the other lessons if you want to dive into ECL in a deeper sense. There is the download page for all of the stuff that we demonstrated, our GitHub portal, and of course, as always, our community support forums. The only thing I didn't put on here is our email addresses, but I am robert.foreman@lexisnexusrisk.com, and you have hugo.watanuki@lexisnexusrisk.com. So please, if you have any feedback, you want to email us, any questions that you might have, well, we will be here. I think the ODSC West goes for one more day, so we'll be hanging around tomorrow from time to time. So please visit our booth, and thank you for visiting us. We really appreciate it. Let me stop real quick. Does anyone have any questions? Anything on the Slack channel? Let me take a look. I don't think so.
Not so far, Bob. And I'm posting our email addresses on the Slack channel in case you guys want to get in touch with us.
Perfect. All right. Well, once again, on behalf of Hugo and myself, thank you so much for hanging with us for 3 hours, and we enjoyed it very much. We hope you enjoyed it. Please give us some good feedback on this workshop. We want to come back next year and do something else, probably completely different. So we hope to see you then, and good luck with all of your projects in big data. All right, and stay safe, stay healthy, and we'll see you again sometime down the road. Thank you.